Hello everyone. Here we have a pair of 1930 or 31 Ford Model A front fenders. And in this video, I, or someone, we haven't decided yet, is going to be restoring these and adding a side mount well on the left side. Now in doing so, I'm going to point out the problems that these typically have and how to fix them, or at least how I fix them. So starting out, let's identify what we have. So let's look over the condition of these, starting with the left one. Yeah, left one. Now, first thing I notice is like these big flat areas around here are really nice. There's not a lot of dents or cracks that have been welded or really bad repairs all around here. Up here, it's all really nice, especially up front. And this is very uncommon for 30-31 front fenders. Normally, when I see these, they're battered really good. Because they're not very strong. There's not a lot of braces in them. There's only one up here. And they take a beating just normally with the harmonic vibration from the engine and the frame twisting around as it drives. And worse than that, normally these cars, people have been crashing into everything in sight for the past 80 years. Now, quite often I come across people that have project cars they're putting together and they ask me, what do I do with this? What do I do with these fenders and all that? And probably 90% of the time, I just tell them to throw them in the trash and get reproduction fenders. And we're going to talk about that a little for a second. Now, a lot of people don't like the reproduction front fenders because they're not good to go out of the box. They're a little rough. They take some fussing and a little work to make them usable, and they are expensive. But you got to compare that with, like, for example, paying someone by the hour to patch together a really rough original. That adds up pretty quick too. And when they're done, no matter how nice of a job they do, you still have an antique made out of old sheet metal with a lot of patch panels in it. Whereas if you buy a new one, you have a brand new part. So it's something to consider when restoring a car, but these I would actually recommend saving because they're so nice. Taking a closer look, we're looking at the front corner now, which is usually bashed pretty hard on most of these. It looks pretty good. Even the screw holes are really nice. Moving up, you can see the bead has been cracked around this corner, which is very typical. It's been brazed back together. And some of it starting to fail, needs a little touch up. Headlight bar holes have some tears in them, also pretty typical. Doesn't really hurt anything, but it'll probably fix it anyway. The back corner has been rusted through, another typical problem. And it's been patched with a really, really rough weld that's probably going to fall apart on its own. The very back of it, where it meets the running board and the splash apron, are pretty straight. Holes haven't been elongated or anything. Doesn't need much. A big tear on the side, which is very typical of 30-31 front fenders. It's been fixed. I've seen worse ones, but most of them have some kind of damage like this. It's been repaired pretty nice, but we're going to touch it up a little bit. The bead up top has been rusted through and welded back together. The reinforcement for the bolt hole is still there, which is pretty good. They're usually missing. So, all around, not bad. The right side is a little more rough. It's got a lot of really small light dents all around. This corner right here, where it bends down, is kind of opening back out. This part here, where the crease is supposed to fade out, it's kind of beat here and you can't really see the crease. A little rougher up here. Still not too bad. The corner up front is noticeably more rough than the left side. It's a bit bashed in. Screw holes need some work, especially the rear one. Probably need a patch panel. But no big tears or anything. That's not bad. The bead on this edge here doesn't appear to be cracked, but it does have a hairline in it. Headlight bar bolt holes look okay. It's had some tears that have been brazed together on the bottom. This back corner here also been rusted out and touched up. Has a big panel brazed on the bottom of it, which is really rough. And the flange that bolts to the running board has been welded in a few areas. Pretty rough job. Otherwise, the back of it looks pretty straight. Still, all the holes are pretty good. The bead, a little rough. Needs some working. And it's got the rip on the side, but not as bad as the left. And the repair is not too bad. I'm probably going to touch it up a little anyway. So, all around, not too bad. The reinforcement for the bracket is still there, also. So, still usable. Now the first thing we're going to do is mock these up on a frame to make sure they're setting properly, the way they should. Now, where they have been welded, it's possible they've been welded together crooked, and if that's the case, they won't sit quite right. They'll be at some awkward angles, so it's important to find out if that is the case and correct it if necessary. So that's what we're going to do next. Before we put anything together, let's look at the fender brackets. This one, as you can see, is bent pretty bad, and this one isn't much better. This is important because if they're not straight, nothing that attaches to it will be straight. This is a good one out of my collection. As you can see, the mounting points are parallel with each other. And this is a good one compared to one of the bent ones. And as you can tell, at a glance, you can't always tell what's good and what isn't. Sometimes the only way you can find out is the hard way. And while we're on the subject, this is a forged steel bracket. These were used from January through March of 1930. They're a little stronger, and I use them whenever I can find them. And this is a broken one that I got for free. And here we have it mocked up. This is some old hot rod frame that's not really much good for anything else. That's good for this. We have two straight fender brackets on it and a really nice headlight bar. And I measured it out. It's squared side to side, which is really important with this stuff. You want to make sure it's not leaning over to one side or the other, which it's not. And now we can see the condition of the fenders, how they fit. Now the right side, it's already been worked on quite a bit. Straightening it out is the worst of the two, and we'll go over that some more in a minute. And now looking at the left fender, the first things I notice is the crown up front here. It's leaning downhill a little bit. I don't know if you can see it very well on the camera, which is very typical on these. Now looking at it from the back, the end of it is leaning in the other direction. Now before we start fixing anything, I'll show you something. Pick up this edge here, and that straightens out. So a lot of this is just because it's not connected to a running board. So I'm going to prop up the back of it to make it level and see if it helps the front here. And I put some blocks under it, make it level. And up front, it didn't really do anything to help at all. Now, one very common cause for this problem is these tears here where they've been welded back together, because the majority of them have been ripped open here. A big problem these have is the person that welds them back together, they can sometimes take out a little bit of material, which will cause the front of the fender to go down like this, or they can put in too much material, which can cause the opposite problem, or cause that edge to flare up like it was. Now, we ran into that problem with the right side. It had some material removed from it, so because the weld was done really nice, we chose to leave it and just stretched it out elsewhere, around here and up here. This is done by warming this up with an acetylene torch and just putting pressure on it, and that helped out a lot. Another problem is if you look here, it's kind of hard to tell, but this line is starting to go inside from here up, which it should be straight like the rest of it, which to my assumption is probably from crashing into stuff. Probably hit a pole or something across here which pushed this down, and it's holding in that position because this area here is stretched out a little because of that. And we ran into that problem with the other side too. And I'll talk more on that later, how to fix that. But this is what's really important when you find problems like this, is to find what caused it, what specifically is wrong, like what's been damaged or what's been improperly repaired. Because they fit good originally, and fixing something that's not damaged to compensate for something else that is damaged can just make the problem even bigger. Another thing to look at is this repair here. As you can see, this part isn't sitting flat on the frame, it's going uphill, and that's been bent here. So that's been welded together crooked. We had a problem like that on the other side, which has been fixed. It's been patched here and here. Both of them were welded together crooked, causing all this to sit at a weird angle. So that's been fixed. So let's see what we can do about this side. So the first thing I'm going to try to do is fix this. Yeah, that helped some. So I'm gonna try to push this corner down and pull this up at the same time. Oh, that actually looks pretty good. Another thing you'll notice is this line down here. It's actually pretty nice. It's bent a little too much here, but it's got a nice smooth arc to it. There's the right side. Not so much. It's been bashed in a little here. And as a result, this part is coming out a little bit. But once this gets beaten out, this is probably just going to tuck right in where it should be. Next we'll go after this disaster of a patch panel, and from the looks of the welds, removing it shouldn't be much of a fight. After cutting away all the damaged material, a new flange has been made and is being welded in. And a patch panel for up top. And it's done. Still needs some finishing work, but it's a whole lot better than what was on it. And this one won't fail anytime soon either. Next we're going to go after the repair here, where the bead has been cracked. As you can see, the wire core is sticking out, and whoever fixed this last time didn't bother to fix that. They just welded everything together. So we're going to cut out everything that's been welded and start over. Now, as you can see, we had to trim quite a bit off of this to get rid of the previous damage and previous repairs. Now, one thing I like to point out is right at the edge here, there's this wire core, which adds strength. And one big problem that people do when they repair these is they don't fix the wire core. They just weld everything back together, and that can put a weak spot in this. So what we're doing here is we got a little piece of replacement wire that we're going to weld in, and we'll weld it, we'll grind it down, trim it beautifully, then we'll make a sheet metal patch panel to go in. And if you notice, we're going to weld the wire in a different location than where the sheet metal is, because that'll spread out the weak point. If you weld both of them together in the same place, that one area is going to be weaker than before it was cracked. This is a remedy that we do that's been working pretty well. The guy who's doing this has restored 2 to 3 pairs of front fenders every year, and so far has had no comebacks whatsoever. So I trust this way of repair. Another thing I like to point out is, in addition to reproduction parts, you can buy just the bead of the fender new, just a long strip of it, and you can carefully weld that onto an old fender, and that will give it a perfect bead. But it's probably not the thing to do with this one because the rest of it is so nice. And that small piece of wire I robbed off of this, which is an old 3031 sedan rear fender. It looks pretty good from here, but trust me, this thing is really rough and really shouldn't be used. So it's good for bits and pieces, which is why I saved it. After the welds have been ground smooth, then the last step is to run over the edges with a file to put the serrations in it. I'd like to point out at this point that the reason the edges were welded with an acetylene torch is because it leaves a softer surface, which is easier to file. Now, looking at the bead, which goes across here, you may not be able to see it very well on the camera, but it comes in a little bit right here and then back out. It's been worked on quite a bit since we last saw it. It was all over the place, but I'm going to show you how I straighten these out. I got a pair of these. I think these are homemade. I'm not sure what they're called. These wide pliers like this, and you just bend the stuff around really easy doing this. Now, one thing to keep in mind is you can do quite a bit with these depending on where they grip. If you grip them up high like this, it'll actually bend it up here, around here. And if you just want to bend the bead part of it, you get it down here. So it's not uncommon on some problems to have to bend it one direction here and the opposite direction down here, which is what it kind of needed way down at the bottom. That doesn't look too bad. Now this dent way down here where it's pushed in, that's double walled back there, and we're gonna have to beat that out from the backside with a hammer. Now up front, here we can see the crown is pushed in a little bit, a little flat across here. And normally when that happens, this part here is out a little too much, so it's pretty easy to fix. Yeah, that looks better. Patch panels for the screw holes are available new for pretty cheap, but some people prefer to make their own. This can be done pretty easily with a socket, a piece of pipe, a countersunk screw, and some easy hammering. After cutting out the damage, it's important the remaining surface be flat and smooth, because it's very difficult to hammer or grind in a small area like this. Now we're going to start installing the side mount well. Now this is a reproduction well that's had the flange cut off so it looks more like an original. And we're marking the outer diameter on the fender so we can get our bearings as to where to cut the fender. Holes are being drilled for welding to simulate the original spot welds. It's important to drill the holes before the flange is cut out and bent over because it'll be impossible to fit the drill inside afterwards. And now we have most of the rough work done on this. So now we're going to get into finishing. Now, for finishing this stuff off, we're going to use one technique, which is called body solder, which is more commonly referred to as lead, which is what this is. We've got a bunch of these at eastwood.com. Now, I want to talk about this technique. This is a very, very old way of filling dents and things like that. It's exactly what you think. You flux the area, you melt this in with a torch, and then file it or sand it. This is a special grade of lead. It's made to have a very soft surface so it can be filed and sanded easily, unlike, for example, electrical solder where it dries much harder. Now, we're going to go through the use of this using this corner over here where we welded in the patch as an example. Now, this has its benefits and its problems. The benefit of using solder or using body solder to fill areas is it's very flexible. As you can see, it will never crack, or at least no time soon, as you can see. So it's really good for like filling in seams and joints. In fact, for many years, cars have used body solder from the factory to fill seams and things like that. It does have its limitations, however. Like, for example, if you have a big flat surface that's just kind of wavy here and there, like most would choose to just wipe a layer of body filler like Bondo or something over it. You can't do that with this. You try covering a big surface like that and filing it, you're just gonna make a big mess. This is good for small areas. Another thing you need to watch out for with this is because it's solder, it sticks to the metal really well, and if you use it on a place that like cracks later on, or if you plan to weld something to it eventually, this contaminates the metal, which makes it a lot harder to weld to, and certainly a lot harder to clean. So it's something to keep in mind before using this. We're using it on small areas around the corners because it's like I said earlier, the Model A sheet metal, it takes a lot of abuse just being used. So everything's on the move a little bit, so it's good to have something a little flexible, especially on these seams here, on these gaps, where that's a stress point. So I'll show you how we do this. First, we're making sure the area is good and clean. Now we're adding the flux. This type of flux is made just for body solder. And now melting the solder on. As you can see, this is quite a technique. It's a trick to get it just liquid hot enough to melt on, but not liquid hot enough to run off. And a bit of practice is needed. A wood paddle helps to shape it. Also being careful to get it at just the right temperature so it can be formed but not run off. After all that is completed, a damp cloth is gone over it to cool it down. And now the skilled and very patient step of filing. This is a body file right here, but you probably end up using several files, sandpaper, even a grinder, depending on what it needs. But whatever tool you use, this is going to take a lot of patience and a lot of fuss. And it's finished. Now, I skipped over a lot of steps for finishing it, but one thing I want to mention is it has been bathed in metal prep, which was to remove the acid residue that the flux left on it. That's important because it can't be painted over. And this is the stuff we've been using for metal prep. Yeah, works pretty good. Now that the serious damage has been repaired, we're down to the finishing stages. So now we're looking for the little imperfections to hammer and file out. Most of these imperfections are so slight they're not even worth messing with. We're just going after the bigger ones that are more noticeable. And that's what we're doing with the bigger imperfections. Now the thing is, if that or a few others were all that was wrong with this, we could metal finish this. In other words, not use any filler whatsoever. The problem is, all of the big surfaces on here are just made of little imperfections everywhere, just from old age. And carefully hammering and filing all of these out would be very impractical for two reasons. One, the hours you put into this would be ridiculous. Two, you'd end up filing a lot of metal off, and that would make sections of this weaker, more prone to cracking. And if it does crack, it'll be a lot harder to weld because there's less metal on it. I have seen problems like this before with other fenders. So for the sake of sanity, we're just gonna put a layer of filler over this whole thing just to fill in and smooth out all these surfaces. Now, before you start freaking out going, you're not fixing anything, you're just smearing Bondo over everything. This is a finishing stage. We've already repaired the major damage, and we're just really putting a really thin layer across it. The way something like this would have been repaired like back in the 30s or 40s is we get a little more fussy with these, just hammering out the high spots and filing them down. Not really getting it perfect, but putting in a lot more hours to get it better. And then coat everything with several layers of primer and then sand it smooth. Now, the problem with that is the old lacquer primers they used, they weren't catalyzed or anything, and they just didn't hold up to the heat or the elements very well. Now, technology has come a long way, and a lot of these body fillers they have today are a lot better. And it's looking pretty good. We're just sanding it down until the high spots show through to keep the thickness as little as possible. I've come across a high spot right about here where the metal is up a little higher than the surface we've sanded it to. So we're going to tap that down just a little. Now this is kind of a tricky technique to tap it down just enough to be smooth, but not enough to where you'd have to file over it or fill over it. And the steps have been repeated until satisfying results happened. As you can see, it's been coated with primer and it's ready for block sanding and painting. And next we're going to look at the underside, or the inside. Now this gets overlooked by a lot of restorers because, well, from about the mid-30s on, most cars you can't even see the insides of the fenders. But that's certainly not the case with these. The inside is very much visible. Another thing is it's a lot more work to finish the underside. It's pretty much you have to go through the finishing stages all over again. One common shortcut a lot of people do is they'll just undercoat the insides. Now, once again, on a later car, that's not really a problem. It's okay, but the thing is, the insides are very visible, especially the side here, and you can really see undercoating from here, and it makes it look like it's trying to be the undercarriage, like you're not supposed to see it, like there's a shield missing or something, and in my opinion just looks kind of tacky, especially on these weld fenders. People just, they'll undercoat the well, and this part of the well is very much visible from the outside when it's done. So I try to put a lot of attention in this part right here because it really does make a difference. Now, in blue ribbon judging, they require the paint finish on the inside of the fender to match the outside. Now, the most critical places that are visible are this entire side, probably from about here out. And like I said, this side of the well and the back of it, like around here, especially if it doesn't have a well, about from here back is visible from the front. What's not quite as visible is this part here and the back side of the well, but should not be overlooked because even if you're not going for blue ribbon, there's a lot of people out there that will just look for something to complain about with your restoration. Now this area right here goes on top of the frame, so it just needs to look okay from the outside. It doesn't really matter. Now this one has already been worked on quite a bit, so we'll look at the other side. Here, looking underneath on the right fender, we can see some spots with quite a bit of rust pitting. This is pretty typical for these, and it's really light. It doesn't really affect the structure any. It's just cosmetic more than anything else. As you can see, some of it's been worked on already. Now, the way we're fixing this is just putting a really thin, tight coat of filler on this and careful sanding, which is more effective than trying to fill it with primer or paint. Now, back to the left side, I'm going to point out a few other things, like these hammer marks. There's a handful of them all around here. Some of these were here before we got the fenders, and some are from straightening dents. Now, like we showed earlier, to hammer out the dents, you can file the hammer marks out from the outside, but you can't really do that from the inside. So the next best thing is to just fill over them and sand it smooth. Another thing I'd like to point out about the underside is it doesn't get the exposure to heat or light like the outside, so any material you put on it is less prone to failing. So you can really load filler on the inside if you have to, which we don't have to with these because they're so straight. For example, here's a car that's currently being restored, and as you can see, quite a bit of the inside of the fender is visible. And almost all of the well you can see also. Okay, it's a few days later. The undersides have been finished and the fenders have been sent out to get painted, and now they're back. Obviously, we skipped a lot of steps. I could have spent at least an hour talking about every subject like welding and hammering out dents and using lead. This video was not really to teach how to do those trades. It was merely to point out the typical problems with Model A fenders. So let's talk about the cost. Now, the guy who did most of the work kept track of the hours. Now, the right fender took 20 hours for the body work. The left didn't take quite as long, but installing the well made up for it, so that was also 20 hours. And both took 11 hours each for prepping, painting, and polishing. That's 62 hours in total. And if that doesn't add up to 62, then I did something wrong. Now, like I said, if you're paying someone by the hour to do this stuff, it can add up pretty high pretty quick. And that is something to think about if you're considering doing a complete restoration. Now, luckily with the early Fords and the parts availability of them, you're not necessarily stuck with whatever you have. If you want to find better original fenders, they're out there. If you want to find new old stock fenders, you search hard enough, you can find them. Of course, that stuff's going to cost money too. And when you start thinking about what that's going to cost, the battered originals, they don't seem too bad. Another big consideration is, like I said, reproduction fenders. Buying new ones, having them shipped to your doorstep, and just drilling holes and finishing them off a little bit. That can be convenient too. So what's the right answer? Well, it all depends on what you're doing and what you expect. But that's one thing I absolutely love about not just the Model A's, but the early Fords in general, is there is just so much available for them. Well, that was quite a journey. So, if you're still watching this, thank you very much. And while we're on the subject of restoring old sheet metal, this is something that has been a special request for a while, and we're finally going to do. This is a comparison between two pieces of sheet metal. This is a piece of 20 gauge steel, which is off of an original Model A fender. It is commonly, affectionately known as Henry steel. This is a piece of 20 gauge steel from the hardware store, commonly referred to as hobby metal, which is what most reproduction sheet metal parts are made of. Now we're going to run a test on these. We're going to take them one at a time and bend them forward and back until they crack and see how many times we can get them to bend. Now, on one hand, this is kind of unfair because the original steel is 80 years old and has been through who knows what kind of abuse. On the other hand, it's very fair because this is exactly the conditions restorers have to work with today. First, the original piece. And there it is. And now the new piece. Well, that was fun.